Hi everyone, in this lecture we are going to talk about image manipulation. Any image, whether it's a JPEG image or a PNG image, when programmatically represented is basically an n-dimensional array. Every cell that you see depicted in this image holds some value to represent a single pixel in the image. Now, what exactly is this number that can be used to represent a pixel depends on the type of the image. Let's say we have a colored image, then every pixel will require that RGB value to represent color. RGB stands for red, green, and blue. For color images, each of these R, G, and B have an integer value assigned to them from 0 to 255. This is how you would represent a pixel that is red in color. R value will be equal to 255, G and B will be equal to 0. A green image, on the other hand, will have the G value set to 255, R and B will be equal to 0. A blue pixel will also follow this convention. The R and G will be equal to 0, and the B will be equal to 255. So we have three values to represent color. These are the three channels of a colored image. Colored images are three-channel images. Now let's talk about grayscale images. Images can also be represented using grayscale. Here we just need one value to represent a particular pixel in this image, and that value represents the intensity of that pixel. Every pixel's intensity information can be represented by a number between 0 and 1. For example, a grayscale image will be a matrix where every pixel can be represented by one value. A single channel image, and the value is to represent the intensity. So in conclusion, we have two different kinds of images. We have the two basic kinds of images that can be represented by arrays are single channel images and multi-channel images. So given this information, you should be able to figure out that images can now be represented by a three-dimensional matrix. The first two dimensions are obvious. They represent the height and width of the image. Along with the third dimension are the numbers that are used to represent the number of channels in an image. For a colored image, the third dimension will have shape 3, and for a black and white or a grayscale image, the third dimension will be 1. So if you have a 6 by 6 grayscale image, the shape of your image will be 661, where 1 represents the pixel intensity. This is a single channel image. In the case of a 6 colored image, the shape of the matrix to represent the colored image will be 663. 3 refers to the number of channels in a colored image. RGB values to represent a single pixel. Now that we have understood how images are represented, we can move on to our lecture and examples of image manipulation. So what I'm going to do at first is let's go ahead and let's import NumPy. So I'm going to say, okay, let me just close this one. So let's click import NumPy as NP. I'm also going to import matplotlib. So I'm going to say import matplotlib.py. Come on, buddy. PyPlot as PLT. Now we are also going to okay, it's mat import. All right. We are also import. There we go. We are also going to import the SciPy library. The SciPy library is the Python-based open source ecosystem for all kinds of mathematical and scientific software. So we are going to say from SciPy import nd image And we are also going to import from SciPy, import the MESC function. There we go. First, let's create a random image. So I'm just going to call it F. We are going to grab our MESC function and we are going to say face. This is going to be the face of the image. Now, the shape of the image. Let's take a look at the shape of the image, and then I'm going to tell you what actually that shape is going to represent. So if I say if that shape, it is going to have 768, which is the height of the image. 1024 is the width of the image, and 3 refers to the number of channels in an image. In this case, this is a color image that has 3 channels for RGB values. So this is not a grayscale image. This we know so far. This is a colored image. This is an image of a raccoon, but we are going to take a look at that like in just a couple of minutes. Let's take a look at the type of this F as well, and we can see that it is it has been represented using a NumPy array. It is an image of a raccoon, and it says that the type is an n-dimensional array. If I were to go ahead and print this F, printing this array shows the RGB colors that make up the image. So each row represents RGB for 1 pixel. Each value is an integer from 0 to 255. Now, let's take a look at the image itself. So I'm going to come in here and I'm going to say plt.imshow, and let's just call this image. This is going to display the image for us. plt.imshow. Okay, let's pass in which n-dimensional array it is that we want to take a look at the image for that. There we go. So it is an image of a raccoon. The image is a NumPy array, which means we can perform the slicing operations on it to select only a portion of the array which represents the image. So if I were to say A is equal to, let's grab F. So I'm going to say, give me 384. Okay, where am I writing? 384 for the first dimension, 512 until the end for the second dimension, and all of the channels. I want all of the channels, so I'm just going to provide in a comma. And now if I just run this, let's take a look at this. So I'm going to say plt.imshow. This imshow function is going to grab any n-dimensional array, and it is going to show you like the image representation of it. So if I pass in A, and if I say plt.show, let's run it. So what it has done is it has selected from the grid, or from the element of the array, starting from 384 in the height, 512 in the width, and all the way to the end, and it has selected all the 3 channels. That's why it is still a colored image. We can also split the image into 2 equally sized portions. The default split is going to be a vertical split. So if I say A1, A2, np.split, we have already talked about this. Let's pass in the array and let's pass in the number of portions. And now let's print, not print, I'm going to say plt.imshow, pass in A1, plt.show. I'm just going to copy this line, just copy it, let's run it. I have misspelled that. There should be an O there. M is also missing. There we go. So by default, the split is going to be vertically. We know when the split is vertical, we have talked about that, how there is going to be a horizontal line that is going to split them vertically. We can also take a look at the A2, which is going to contain the bottom half of the image. There we go. We can also split the image into 2 vertical lines. So for that, I'm going to say we can also split it horizontally, and then we are going to get two horizontal portions, not vertical. I'm going to say np dot split, and okay, this is applet split. First we need to pass in the array, then the number of portions, and then we need to change the axis. The axis is going to be 1. It's going to be equal to 1. Now I'm going to do the same thing. So I'm basically going to say this is going to be B1. Let's represent that. There we go. So for horizontal splitting, we have a vertical line. And this is going to be B2. This is going to be the other portion. So the left portion of the image and the right portion of the image. If we go ahead and put two NumPy arrays together with the concat method, we can basically grab the image and put it together to form a whole image. So for that, I'm going to say plt.imshow, and I'm going to say np.concatenate. Let's grab our A1. And I'm going to grab the A2 as well. But because this concatenate only grabs one argument, I'm going to pass a tuple of values. So I'm going to say A1 and A2. There we go. Let's grab plt.show. And now if I run it, we have our complete image right here. Now, what if we do this for the horizontally split portions of the image? How is that going to work? So I'm just going to copy that just to save you some time. I'm going to change this to B1 and I'm going to change this to B2. Now, before actually running this code, I have to tell you that the concatenate method stacks the array one on top of the other or column wise. So even though B1 and B2, they represent parts of the image, like the left side and the right side, it is going to stack them on top of themselves. So we're not going to get a full or whole image. We're going to get something weird like this one. Now, we can also shape we can also change this behavior by providing like an argument. And that will concatenate the array row-wise. This is the default behavior. We can also change the shape of this array. So if I put it right here, now keep in mind for the concatenate, I'm going to provide a tuple values for the array, but I'm also going to provide another argument that is going to be axis, and I'm going to set it to 1. Now, this is going to concatenate it horizontally or row-wise. With this, our image manipulation lecture comes to an end. See you in the next one.